Hey everyone, thanks for joining. In today's session, we are going to see about Kubecost, which is basically a cost monitoring tool for Kubernetes cluster. So this Kubecost, helps organization to calculate the cost of your Kubernetes cluster in real time. It gives you a lot of information about the cost. And, it provides a lot of metric information also, which will be like super useful, when your workloads are running in your Kubernetes cluster, right? So like this was like founded or the development, started in 2019, I guess, by two of the former Google employees. And then, eventually started as a open source project and then now, become a product itself. But, the product has got the free tier edition also, like other than the free tier edition, it has got like business and some enterprise edition also, right? So there are a lot of movement to the cloud, right? During the pandemic or even before pandemic, itself, the cloud got popular and all the clients are moving, or still, the migration is at, fast pacing, right? So there is a famous assumption that, cloud is cheap, basically it is not, until or unless you manage it properly, it is, super costly. So in that sense, when your workloads are getting deployed into the Kubernetes cluster, the calculating the cost of the Kubernetes cluster, becomes very tedious also. Right? Running like one Kubernetes cluster can be used by multiple teams or projects or multiple applications also, right? So in that sense, so at that time, who is spending how much of the resource is using that particular team or that project or at that application against the cost, calculation of this, is very, very difficult, right? So this cube cost, greatly helps us to find and calculate the cost of your Kubernetes cluster. And it has like a lot of other benefits also, which we'll be seeing in this session. So the agenda of this session is going to be introduction about Kubecost, little bit of introduction and the architecture. What are the components, make this Kubecost, it has to be implemented in your Kubernetes cluster only. So what are the components and plays a role in setting up this Kubecost? And then the implementation itself. So the implementation is actually quite simple, it's Helm-based implementation with few commands, you'll be able to fully set up actually. But understanding about all the other things are actually very important in the implementation, since it's very simple. And then, yes, once we implement it, so for the implementation purpose, I'm going to deal in Azure. So I'm going to have Azure Kubernetes cluster. And then, I'm going to do all these setups and yeah, the Kubernetes is going to run from the Azure Kubernetes cluster. And then like once we set up, we'll explore, the Kubernetes Kubecost, dashboard, what are the features it is providing, what are all the, in terms of, how to see the cost calculation it is making, and then like, everything, all the features it is providing. So all this data will be seen in the Kubernetes. So first, the challenge part is like when you're working in a Kubernetes cluster, like could be used by multiple teams or projects or even applications also, right? So in that manner, to calculate the cost, who is using, how much of the resource quota and make a cost calculation based on that, it becomes a very difficult task, right? And if you try to do that, manually, it becomes very complex, right? And probably like you need to do your own automation, probably to manage that, and all these things are like very complex. So here like Kubecost helps to solve that issue. That's the solution it is providing. And some of the prerequisites is like supported Kubernetes version, it should be like above 1.8 and recommended is 1.25, and supported Kubernetes cluster, right? Can be deployed into like famous cloud providers, public cloud providers, and also this can be deployed in on-prem to view your data, right? And then the supported cloud providers for cloud integration, cloud billing integration, if you want to make at the moment, like only Azure, AWS, and GCP are supported at the moment, not more than that, right? And coming to the architecture, so So as I said, like, it's a Helm-based, deployment. So when you deploy, there are like a couple of other components also gets deployed along the way. So basically, a Kubecost, a dashboard or UI, will be created. It's basically a deployment, and you get a dashboard or UI. And then underneath, you could see Prometheus. People are working in Prometheus. Yeah. So Prometheus, it's getting deployed. So this is the background, or the backend backbone itself. I would say. Uh, the Prometheus is basically, collecting metrics, right? From kube state metrics, node exporter. Node exporter, is basically deployed as a daemon set in every node, like how many nodes you have. It is deployed as a daemon set, right? And then like container advisor and network metric, all these metrics are basically collected by Prometheus. So Prometheus, as you know, like people who are working in a time series database, it collects metrics. So yeah, Kubernetes has this metric server, and it uses metric server API, exposes that API, and Prometheus will be able to collect the metrics from the API basically. And the Kubecost is leveraging that. Okay. So using that metrics, it is actually calculating the cost. And apart from that, the billing data. So as I said, like, you can make, cloud integration also depends on the cloud provider. So when you do that integration, you'll be able to see the Kubernetes cluster cost along with your cloud billing data cost also, right? So this is what a simple architecture. And apart from Prometheus, like, you will be like Grafana also will be deployed actually. So whatever the data you are seeing in the Kubecost, that will be, similarly you can see that in Grafana also. So all these things, I'll be showing, when we do the implementation. So the installation, this is what the installation looks like. I'll just, go to the official, documentation itself. So if you go to this kubecost.com and resources, and if you go to docs, so you'll be able to see, all the docs relevant to the kubecost. And if you go to the installation section, you'll be able to see how to do the installation. It's a very simple installation, as I said, that, with some Helm commands, people who are familiar with the Helm, they can easily do it. So basically, this is the command, as you can see here. So you need to create one namespace called kubecost, and then the Helm deployment will be done in that namespace. So this single command, will be able to do that actually. The Helm upgrade, install, kubecost, and then like this is the repo node is getting all the files from, and then the namespace, basically you're creating a new namespace. So with this, you'll be able to deploy the the kubecost into your Kubernetes cluster. And then there are like other ways also provided to do the implementation, but this is basically the recommended way to deploy actually. Yeah. So for this demo purpose, what I will do is, I'm assuming that, you have some knowledge with Kubernetes, and so the implementation, the mechanism, it's going to be the same across, whatever the cloud provider you have, whatever the cloud, you're going to work with, it is going to be the same actually. So for the demo purpose, I will create one Kubernetes cluster just for the demo purpose. So, so we have created our Kubernetes cluster. So let's try to access the cluster. So get the credentials. So just check, wanted to check, which cluster I'm in. So it's in it's good. So I'm in the correct cluster. Okay, so just see, get all the namespaces. So there are only like four namespaces. This gets created by default. Okay. So let's do the Helm. Let's run the Helm command. Right? So yeah. So if you go to Kubecost and installation page, so you can see this command basically. So just copy this. So before that, just run helm repo list just to see, whether we have it installed. Okay. So, I think I'm seeing. Okay, so this is available because I have deployed in one of my cluster actually. So that is why we have the Kubecost repo list actually. So just run this command. So so you are you are installing executing this command in namespace Kubecost, right? And it is creating new namespace automatically. So just run this and wait for a few minutes. So this is like, as I said, like this is a straightforward way. There are other ways, using Kubernetes manifest files or the Kubernetes, custom resource definitions also like it is possible. But as you can see here, uh, there is some custom resource definition also, the manifest file. So this is the straightforward way, like this single command, it will be able to deploy. Once deployed, yeah, I think it's deployed. So we'll just check get all space to cost. Okay. So in namespace Kubecost, as you can see that all these things are getting deployed. So if you see the deployment, apart from Kubecost analyzer, Kubecost Grafana, Prometheus server and kube state metrics also getting deployed. As I said, in the architecture, the Prometheus is the backbone. Basically, it is only like collecting metrics, and from that metrics only like kube cost, making all that cost calculation. So whatever the data we are seeing, we see in the kube cost dashboard that can be viewed in Grafana dashboard also. Okay, I will show you that also. So at the moment, as you can see, so how to access reach the Kubernetes, sorry, the Kubecost dashboard. So if you see the services, there is Kubecost analyzer, right? So this is created with cluster IP by default. Okay. So if you need to access, what do you need to do? So you need to change the service type from cluster IP to load balancer, right? So I'll quickly change it. So just if you want to change from cluster IP to load balancer, just go to the bottom and there will be a type property. And just change that. Okay, it's as simple as that, right? So if you check uh, services only, right, you can see that for your cost analyzer, the external IP is getting created, right? It's pending. So basically, a load balancer is getting created. So you'll be assigned with a public IP, and if you access the public IP, you will be able to see the data. Okay, so with port 1980. So we have created the Azure Kubernetes cluster and we have run Helm deployment commands and we have changed the service type from cluster IP to load balancer. Okay, so get that load balancer IP and paste it here, with port 1980, and you'll be able to see this beautiful dashboard, Kubecost dashboard. So this is the front end or this is the UI or dashboard, when you access, first, right? So the front page, gives you the overview information. You can see here the Kubernetes cost. Basically, it's a 7-day cost. I'll tell you like how the cost and all being calculated, but this is the cost for one cluster. So it's a one node cluster, so it's $0.23, say 70 cost, okay. And then it is showing cloud cost, okay. So I have made integration to Azure cloud, like one of the subscription. So, and it is getting that data from that. So it's my cloud cost, okay. So total cost is basically sum of Kubernetes cost plus cloud cost. So that is what, we are seeing here, and possible savings. So as I said that, it's not only providing the Kubernetes cluster cost, like it's not only giving you the information about the cost, it is also providing you the possible savings, in terms of recommendations and advices, and by analyzing your Kubernetes cluster and how much of the resource, being requested and how much is actually used, based on all those parameters and metrics. It is providing you a lot of suggestions and recommendations, you can make a possible savings, out of it. So that is what, information is providing. So whatever the savings, possible savings shown here, might be true, might not be true also, but you need to, analyze, because your cluster, right, how much of the workload is there. So you can fine tune it and tweak a bit, so that you can save some cost, by checking these recommendations. And then finally, efficiency. Efficiency is something like how much of the resource being requested for and how much is actually being used, right? When you're under utilizing your cluster, when you're like created with 5 node cluster, but only like 2 nodes are only used, only that much of the workload you're having, which means the efficiency is going to be low. So at the moment, like even though it's a 1 node cluster, like I don't have like much of the workloads, running except the queue cost. So that's why my efficiency is very low, right? And then the cluster. So this is the cluster, this where the queue cost is running, and this is the cluster information. So it's $0.23, and it is showing the active status also. And the trends, like day-wise information, like today only I've created the cluster. So today it is showing the cost actually. And the efficiency. So the efficiency is calculated based on these three things, and also like few other things. So CPU, RAM, and storage. So as you can see here, for example, if I go to RAM, the usage is 0.01 and allocation is 0. Okay, and the ideal is 0.02, which means that the usage is very less, and the gray color highlighted, that is basically ideal. So like, which means that you can take some decisions and tweak your cluster, or your nodes resource quota, so that you can say do some savings, because the ideal is actually more. So this is like a newly created cluster, but if your workloads are running for a long time, then probably like you know it very well whether that is explicitly required or not, right? And then like you get to see like namespace wise data also. So in this Kubernetes cluster, like there are two namespaces only. So we have our Kubecost namespace, and then the Kube system, will be created by default, all the Kubernetes, API elements and relevant systems, will be running, right? So, and the cost-wise data also for each namespace, right? And the namespace trends also, like you are seeing the namespace-wise cost data, like graphically. And then like I have made integration to one of the Azure cloud subscription. That is what the data you are seeing. So if you're working with different cloud, you can make integration to that cloud. I will tell you the steps. Will be little different from each other cloud provider. But for Azure, like I will be giving you that information. So when you make that integration, you will see the cost, and along with that resource with cost also. So the subscription or the resources are basically used, and the resource based cost information also, like we'll be seeing, right? So that is what the simple overview. And if you see the left side panel, these are the features or the functionalities, we'll be getting from the Kubecost. So basically the monitor. So the monitoring, uh, you get in allocations and that's it. So allocation is nothing but, based on the Kubernetes concepts, you'll be seeing a lot of data. So when you get into allocation, as you can see, it's a last 7 days data, and it's namespace. Okay, so namespace wise, how much of the cost, not only the cost, with a lot of other metrics. Okay, for example, we have like two namespaces as you have seen, right? So cube system and cube cost. So cube cost, as you can see, for CPU, $0.02, and GPU, RAM, and persistent volume, network, load balancer, and there is any shared cost. So based on all these things, it is making this calculation basically, and it is calculating the efficiency also, like. this namespace, like it's 75.9, whereas cube system is 9.3. So as you can see here, the cost is calculated based on all these things, right? So when you create a cluster, you get created with disk and all these things. So shared is something that, for example, if a database is created and if it is shared between namespaces, that will come under shared. And there are like other components, which will act as a shared component, right? All the namespaces, will be using. If at all, you want to see, I don't want to see it splitwise, namespace, I want to see with a different view, right? So you can always click here, you can check. Okay, for example, if I click node, you can see, for example, this is a one node cluster, that's why I'm seeing for this particular node. So it's $0.14, right? So you can see the ideal information also. So ideal is like 0.10, which means that it is not used for some time. So which is basically a vital information, so that you can tweak your cluster a little bit, so that you can save some cost. So if you see here, there is a single aggregation and multiple multi-aggregation. So based on the Kubernetes concept, you can see this view. Basically, for example, pod wise, there are a lot of pods running in all the namespaces, which can be viewed here. So basically, the point is, based on the Kubernetes concepts, this allocation feature, it's basically giving you all the information, and it is taking into account uh, the cost is calculated, based on the CPU, GPU, and all these things, right? So, and yeah. So, and also like you can save this data, you can export this data also, whatever you are seeing in this page. You can download this PDF or download as CSV, and you can create alerts out of it. For example, I will try to create it as a PDF. So I'll open this and you'll be seeing a report actually, right? You don't see the graphical view, but you get the data from the PDF point of view, and you can create CSV also, right? So this is with the monitoring aspect, with respect to the Kubernetes concept. How namespace based on the Kubernetes concept wise, how the cost is being allocated, how much of the resource being used, uh, based on all these parameters, right? And next is assets, which comes under monitoring again. So asset is something that the when you create the Kubernetes cluster, for example, in Azure, there are other resources which gets created along with it, right? So which means that along with your nodes, actually, like you create a load balancer, or I mean a disk, will be created, all these things, right? So from the Azure side, the resource wise, you get the information also. So for example, this is like 7 days data. Uh, so and this information includes, Azure billing cost also. So that is what you are seeing here. Uh, yeah. So if you see here, the Kubernetes cost is 0.25 only, and there are like other things. Yeah, let's see that. For example, if we see 1 day data or something, uh, we'll be seeing only the Kubernetes cost actually, right? So this is basically a combination coming from Azure billing data as well as the Kubernetes cluster. Okay. And then, for example, like I want to save this data. Okay. Example, I'll save this data. Last 48 hours will be okay. See, for example, like if you are visiting this quick cost dashboard, like you will be changing a lot of things to get different views of data, right? So all these things you can save it. So next time if you come here, if you go to reports directly, you'll be able to access that. So just now I've saved last 48 hours of data, right? So if I visit this, if I click this, you'll be directed to that selections, automatically, without you do the manual selection. So that is basically the report page, and you can create as many reports you want, and yeah, all these things you can see, and this can be exported as XML. Yeah, I think, from using when we are doing the health-based deployment, right? At the time, it's in the values.yaml file, we can probably like pushing this data so that, instead of creating this manually from the dashboard here, we can deploy it, implement it from the Helm during, Helm deployment itself. And as I said, like, it's not only giving you the cost information, it's also giving you the possible savings, where exactly you can do the savings. So if you check this savings page, so based on a lot of topics, it is giving you a lot of suggestions and recommendations. For example, right, so it's your cluster nodes, based on containers, based on reserved instances, abandoned workloads. So you can see for yourself, based on disk, So for example, based on disk means, the kind of disk, you are using, or probably like it is giving you recommendation, certain recommendations. For example, I will go to like one of these things, it is saying that, you can save up to $19, right? If I go inside this, it is giving you all the information, first of all, right? So current is, if I run this as a one node cluster, like it will cost me like the $36 per month, right? And it is giving some recommendations, some complex recommendation and some simple recommendation. Okay, so which will save me some $21. How it is going to save? So it is giving you that information. Like CPU currently, like I have the two vCPUs. Based on recommendations, like I can go up to like 4 CPU and 3 CPU and things. Okay, so if you drop down this instance breakdown, you can see this. Currently, at the moment, I'm using B2S, right? So which is basically two vCPU and 4 RAM. Okay, so what it is recommending is you can go for like B1LS, B1LS, and B1S, one B1S. So you can get a 3 node cluster, and the cost also will be reduced. This is kind of some complex solution it is saying, and this is like recommendation simple load. Okay, you can go for like 3 node V1S cluster, so which will cost me like for each node $8 per node, and it will be like $26. Okay, so whatever it is showing here, it might not be accurate also, but you get a lot of information, right? So based on that, you can take decision, whether this will be like useful, and whether this is correct or not. You can take a decision, but the important thing is, it is giving you a lot of information. That is what, right? So likewise, you can go to other things also. For example, you can right size your container request, right? So for example, it is saying that this particular container, it has requested RAM of 70 milliunits, I think. So RAM recommended is only 52. Okay. So CPU requested is 100 M, and CPU recommended is 10 M only. Okay. So requested and recommended. So it's basically the current efficiency is only because you are underutilizing. So the efficiency is currently like 4.65 only. So it is giving you these recommendations, each container, how much it is consuming. So yeah, this is, kind of vital information. You can take a decision, based on. So like that, likewise, there are a lot of, based on a lot of different concepts, it is giving you a lot of recommendations, right? But it is not going to remediate anything. It's not going to apply the changes or something, like it does not do anything automatically, right? It is going to give you only the recommendations and stuff. And there are alerts. You can create alerts. So when you go to monitor dashboard and something, when you create some alerts, you can create some alerts based on that, and that alerts, can be pushed to Slack page or Microsoft Teams or subject, and then like some emails also, like you can have. So we'll see that also, right? And health wise, this is also like another important feature. So based on certain parameters, for example, phasing compute pressure, memory request nearing cluster capacity. So likewise, pending pods, recently failed jobs. So based on all these things, it is making some health prediction, right? So at the moment, it is saying that, my cluster health is 94%, right? So it's basically assessment of your infrastructure reliability and performance risk. Okay, you can see these things. I think, we cannot add anything on our own. So what has been listed here, based on that, it is making, it is giving you the health score, which is, good in our case. So if you don't show all, if you see here, there are some warnings. Work nodes not spread across multiple failure zones. Cluster does not have replicated master. So this won't be suitable for Azure, right? It's a managed cluster and managed by Azure. So likewise, it is giving you some information, right? You can take some decisions from that. And finally, some govern. So budgeting and all these things, does not. It's a pre-edition, as you said, does not come here. So this feature, won't be useful. So if you see here, so as you can see, this is one node cluster and only one cluster, right? So the pre-edition at the at the same moment, like, we'll be able to see like only one cluster at a time, right? You cannot see unified view of multiple cluster and all in the same dashboard. So which comes in enterprise edition, okay? In the pre-edition, you can see only like one cluster. So previously it was like, there are three editions, but the pre-edition, like at any point of time, you can deploy kubecost in like only one cluster, and you'll be able to see like only one cluster at any point of time. And then like later, recently, they have managed to give the feature like, you can see like multiple cluster also, but not the unified view, right? So what does it mean is like, if you see here, this is the cluster, I'm accessing. Likewise, you can add another cluster. For example, if you have like another cluster, and if you have to deploy the kubecost, the same kind of setup, what we have done here, and you get one public API, right? That public API, if you paste it here, then you can switch between, different cluster actually. Then you'll be able to see the other cluster data also, but not the unified view, right? So that is what, it is providing. Okay. So, coming to the important point, so the cost it is showing like $0.26, right? So how accurate it is? That's a very important question, right? Everybody will definitely be interested to know that, right? We are seeing this data, whether we can believe this data or not, because once you're deployed, this definitely will be looking into it, and you have to believe in this data, right? So how accurate it is. So during agenda, like I mentioned that integrating the billing, Azure billing rate card API, right? So it needs access to the cloud. For example, this is AKS, deployed in Azure, right? So it needs access to Azure cloud provider billing rate card API. So that rate card API is provided by Azure. So it needs access to that rate card API, so that it can get that accurate cost, basically, based on the region, based on your subscription, and based on your billing details. It will be able to collect and predict the accurate cost, and then uh, it will show the data. Otherwise, it will be like mostly it will be like predictive in nature, and the cost won't be accurate. Okay, so to do that integration, coming to this, so do that integration, we have to do certain integrations. Okay, so integrating Azure Billing API for it is easy. Okay, so and you can see the same in first. So here, if you see in the cloud billing integrations, there is cloud integration, Azure cloud integration. Likewise, you have other cloud integrations also. The Azure rate card configuration. Okay, so what did he say? Kubecost needs access to Microsoft Azure billing rate card API to access accurate pricing data for your Kubernetes resources, right? So that is what. So for this, what you need to do? So you need to create a service principal with this role definition. So these access your service principal, basically need. Okay. And then once you have created that service principal, uh, you have to create a file called service-key.json, and in that file you need to feed in all your service principal details. So when you create the service principal, basically you will get app ID, display name, and then the secret, right? And then the tenant ID. All this information you need to feed it here, and then like you need to create a file, a service key.json, and using that file, you need to create a secret. Okay, so kubectl create secret, and this is a generic secret, and this is a secret name, and in the namespace kubecost from file this service key.json, this is a file. Okay, so basically, as you can understand, how it is working, right? So we have a service principal which is having access to what? So you can see here Microsoft Commerce and rate card. Okay, so it is reading the rate card and it is reading virtual mission VM sizes based on your virtual missions and a lot of other things, right? Location and your cloud service provider and container services. So based on all these things, like it will be able to predict or provide you the accurate, cost data. So within this scope, it has all the permission, this service principal. So basically, you create a file called. So you create a role, basically, to cost role, and that role, when you're creating a service principal, so you assign that role. Okay. So you create a file again here, a file called myrole.json, and using that file, you create the role definition. Okay, and that information is provided while creating service principal. Okay, we'll see this. Okay, so 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 as per the steps mentioned, once you have created the service principal and once you have created the secret. No, so just check your cluster, uh, get all the secrets, and you'll be able to see the Azure service key, right? So Azure service key, this is the secret you have created, right? And once you have created the secret, you need to like the Kubecost need to know, right? So there is a service principal, which it can use to access the rate card API data, right? So the information has to be informed or integrated to Kubecost, right? So simply use the Helm command, Helm using the values file, you can pass it or you can use, set values, right? So, you can see here, these are the ways, you can pass, Helm values, you can set the values. Otherwise, you can run a simple command. uh, you can see here Helm upgrade cube cost, and then like I'm setting this value. Basically, what I'm doing is cube cost product configs dot service key secret name. I'm passing this as the uh, secret name. Okay, so passing this to the Helm. So once this has been passed, so how to ensure how will we ensure that the rate card has been integrated? So if you go to the uh, cube cost, and if you go to settings, so there will be general pricing and diagnostics. Go to the diagnostics and see the full diagnostics, view full diagnostics. Okay. So when you run this diagnostics, so it will be running all the diagnostics, in the sense that, whether all the connection and integration are proper or not. So if you see here in the pricing resources, the rate card API, the integration to the Azure is set, basically. So you get a green signal, right? And green tick mark, which ensure that you have integrated to the Azure API. Now we will see. Okay. So if you go to that, whether the cost are coming accurately or not, right? So I will go to like sorry. So, we'll go to the no. See the cost. So if you see this, right? So this is our cluster, and all the other cluster information. So if you see here, it ran for like 4 hours. So today only I created this, so it ran for like 4 hours, and the hourly rate is actually 0.50. Okay, the total cost is 0.20. So likewise, what you can do, and the node breakdown, in terms of CPU, RAM, and GPU, right? So basically for standard B2S, so we are just checking like one of the resource, we are trying to verify it, right? So in this case, like I'm taking now, since we're using virtual machine scale set, like since it's a one node cluster, so like only one node. So for this node, the hourly rate is 0.50 and the total cost is 0.22. Okay. Let's go to Azure billing, Azure virtual machine cost calculator or something. So go there, go to virtual machines. So what I'm doing is, it is calculating based on certain things, right? So here in this case, like it is calculating. So it is assuming that the node cost for the standard B2S is hourly is 0.050, right? So we can cross verify that, right? So virtual machine. uh, okay. So it's Windows, I think it's Linux. Um, let's keep this and standard B2S. So you can see here, standard B2S 2 cores, it's 0.050, right? So this is what the cost, we are seeing here. So which means that, the rate card API, it's getting the correct value and your, the cost calculations will be like accurate, right? So this is how, you can cost verify. So just for sample, I have taken like one of the resources since it's going to be the primary cost factor, node, right? Other resources are going to consume less cost, right? So this is going to be more cost. So I've taken this to show you like how far the costs are actually matching, right? And yeah, so coming to so this is how the rate card API integration works. So for our agenda, so integrate cloud billing, right? So the rate card API helps to get So it helps to assume the Kubernetes cluster cost rate, predict accurately. So now, as I said, like along with Kubernetes cluster cost, you can view your cloud provider cost also. Like in your case, whichever cloud provider. I think at the moment, like only three cloud providers are supporting Azure, AWS, and Google. So when you do the integration, like you'll be able to see that cost. So as you can see here, my cloud cost is basically 396, and you will be able to see the same data here also. So to do that again, so to do that, basically how it is basically happening is so when you go to your cloud, uh, so this is my cost. Okay. So when you go to your cloud and subscription, and when you select your subscription, this is what the page you'll be seeing, and you can choose the cost analysis. Okay, so this is like a default dashboard the Azure itself providing, right? The FinOps kind of dashboard Azure itself providing, and you can change the dates and you can change the subscription, and you can add filter like based on resources or a couple of other things which you're interested. You can see the data, right? For example, resource, and for a particular resource, we'll be able to see the data, right? For example, a case agent will be able to see the data, right? So likewise, since we're integrating our Azure billing, so how the Kubecost can access this cost analysis is, it is leveraging some Azure feature itself. So in this page itself, if you see, there is configure subscription. So basically what we are doing is, we are exporting this page or, the information like the day-wise data, right? The information we are exporting it as CSV and uploading to the storage account. Okay. And then like from Kubecost, we are making integration to the storage account. We are connecting, the Kubecost is connecting to the storage account. And then based on that, it is providing the data in the dashboard, which we are seeing. Okay. So if you go to configure subscription, so this is what the setup, you need to do from the Azure side, first of all. Okay. You can go to export and you can add, for example, what is the export name you want, right? And then like daily, like I need to I need to create a CSV out of it and I need to upload to the storage account. So, and again, here you need to provide the storage account information. Okay. So this information. So I have already created a storage account and I have already created the export and I have scheduled it. Okay. So if you see here, so this is running on daily basis for me. Okay, I have scheduled it on daily basis. So this will be running at a particular time. The data will be available. So what from the Kubecost dashboard, for example, since it is running on daily basis, for example, like 8 p.m. on daily basis. If I'm checking on 7 p.m., then my data will not be accurate, right? Because it will hold the data till like last day's data only, like it will be having, right? Because the next day, like only like at 8 p.m you will get a new report. So you have to see like before 24 hours or 48 hours to get your correct data, right? So this is scheduled and this is running on daily basis and it is getting exported as a CSV file to the storage account. Okay. So this is my storage account I already created. So this is the container I have created. And yeah, this container folder I have created. So inside this is what the export page is creating. So go inside this. So these are the files, CSV files. So these are the CSV files, getting generated. So now, yeah, from the Azure cost analysis page, and also one more thing is like this is the cost analysis page for a subscription, right? Likewise, if you want like resource group, particular resource group data, you want, like you can go to the resource group and you can see the cost analysis, data information. Also, like you can, upload that information, or from here itself, then you can select that resource group. So it depends, right? If you want to monitor and you want to see resource group level cost information of your cloud, then you can see that also. Okay. So yeah, so the CSV file. So now the data, the CSV files are generated and uploaded to the storage account. So how the Kubecost will use this, can access the storage account basically. So how do you basically access the storage account using storage account access key or the SAS, right? Shared access signature key, right? But here in this case, like we are going to use storage account access key, right? So if you see here, in the Kubecost documentation page, there is Azure Cloud integration. So it is giving you all the information, whatever I have mentioned, export Azure cost report, whatever I have shown you. So how to export the cost report. So and that is like Azure page itself. You can go there and it will give you like step by step how do you export your cost information of your subscription. Okay, whatever I have shown. Okay. So yeah, and then provide access to the Azure Storage API. So the Kubecost need to access the storage account so that you can get that CSV file and you can access that data, right? So for that, what you need to do again, as like we did it for rate card API, create a file like this. So the file name should be cloud integration or JSON, whatever, right? But just follow the same as it is. So in this file, like what are the information I'm going to provide? Just your storage account details. Okay, your storage account name, storage account access key. So I guess you are sure how to get the storage account access key, right? So if you go here, you go to storage account. Uh, yeah, so there is access key, and you can get it, right? Use the key. You can get it here, and that information can be here. And then the storage container name. So whatever the container name you're providing, then the container path. This is kind of optional. You can provide or not provide. Okay? Then the Azure cloud should be like public. Okay, so create this file with all these information and create a file called the cloud integration of JSON. And using this file, create a Kubernetes secret, as we did it for record. To create a secret, you can keep any name, and then using the file cloud integration.json is the file. Okay, in the namespace Kubecost. Okay, so we have created the secret. So how can we tell Kubecost to use this? Okay, so we need to update, right? So we have created the QCTL, sorry, the Kubernetes secret, and we need to update the helm as we did, right? So to update the helm, you can set the values with the helm commands, or you can pass on the information using values.yaml file, right? So this is the helm command you can use. So you can set the values in helm command, or you can create a separate file itself, with all the values, and that values can be passed here. Okay. So once you have created the secret, run the helm command, and then you can. So while running the helm command, like this is the value, value file I have created. You see here, this is the secret, which I have created, and I am passing that value to the kubecost, right? So if I check the secret again, uh, get secret, you can see, this is the secret, which I have created, and that value, I'm passing to the kubecost. So with this, you'll be able to do the cloud integration. That data, you can see here, as I said, right? So this is the data you're seeing here, and if you can drill down actually, like granular information you'll be able to see. So with respect to your cloud integration, you'll be able to see what are the resources part of your subscription, and all this information, like you can get it. So with all the tags and information, so it's a lot of information, right? So from a single dashboard itself, you'll be able to see Kubernetes cluster cost along with your other cloud provider cost, right? So uh, like when you after you have done the cloud integration, right? So again, as like we check for rate card API, we got some green tick mark or something, right? Likewise, we get some green tick mark, for successful after successful cloud billing integration. So this is for rate card API. And if you scroll down, so these are all like since Kubecost, depends on rely on Prometheus and all these things, when you run diagnostics, basically it makes sure that all the services related to Prometheus and all the metrics, it is collecting whether it is healthy or not, all those things, it will automatically do it. So and it runs and runs some ETL queries also. So this is what the cloud integration. So normally the cloud integration, as you can see, is a green tick mark, and if you click this, so the connection is successful. Sometimes if it is not configured properly, like there will be like a lot of other error messages will be saying the data not accessible or not integration. So be careful. You might do some typo errors. So be careful with that, and with this, you'll be able to show that. So health have shown, and then the alerts. Okay. So the alerts, you see that you can create alerts and then notify with webhook, sorry, to the Slack channel or MS Office, MS Teams, and then to email also. So I will just quickly give you. So I've created one Slack. Have a Slack channel. So this is my Slack channel, and this is my workspace, and I have one channel here. Okay. So I have done the webhook integration. So hope like how to do the webhook integration. So basically, if you go here and see view channel details, and if you go to integration, and if you go to app, so when you check webhook, so, so yeah, webhook, right? So this is the webhook, you need to install. So once you have installed it, you'll be getting one URL. Okay. So that URL information you need to provide here so that, you can notify it. Okay. So for example, you can monitor cluster health and kubecost health, so by default, you can enable this. For example, I want to monitor cluster health. Okay. So what I'm going to say is, the cluster health, as we have seen in the health section, right, it was showing like 95 percentage, based on certain parameters, right? So if it got reduced to 50, then I need to get an alert, that is what the cluster health monitoring, right? So I think it's not going to come 50, so I'm going to make it as 99 because it's already 95. So like this is like a window of like 10 minutes to 7 days, something like this, right? And this is a Slack group channel. Okay. So it's my channel, and if at all you have Microsoft Teams group, yeah, you can uh, configure that, and then you can add emails also. Some subject, right? Okay, so just test it. Okay, You can save it when it reaches 99 and after 10 minutes, you'll be getting the notification in the Slack. But I want to test it now. So alert sent successfully. If I go to my Slack channel, you can see there is a test message from Kubecost alert along with properties. So which helps basically. Right? So this is like monitoring cluster health on periodic basis. So likewise, you can create some report and then if at all that report reaches certain value, create a alerts also based on that, right? See, you can have alerts and you can create alert actually based on certain things. Okay, so this is a simple monitoring a cluster health and cube cost health actually. So if it goes down, we'll get alert. But these alerts are based on the data you are having, right? So yeah, so this is about the alerts and notifications. Then finally pricing. So yeah, so this is the pricing tiers. So you have the Kubecost is providing a free edition, and then there is two paid editions, business and enterprise. So in the free edition, as you can see that one cluster no size limit. So this has been increased to multiple, more than one cluster, right? But you cannot see the unified view of all the clusters, but you can switch to different clusters. I've shown you here, right? From here. So if you add another cluster, then you can add it from here. And then like 15-day metric retention. So whatever the data you are seeing here, you can see up to 14 days, only. So for example, start date, right? So it's so for example, if I'm keeping 22, then date is today, right? So you are requesting data more than 15 days old. Okay? It's not available for free time. Okay. So which means that you can see up to like 15 days of data only, not more than that. If at all you want more, more historical data you want to see, the setup itself, actually different. And you can see up to like 30 days for business. And for enterprise, I think you can see the long-term history also. And then like from free edition, we'll be able to select, we'll be able to see our utilize features, cost monitoring and allocation, cost saving insights, and risk assessment report of the health related score we are seeing. And coming to the business, so what business have and free edition does not have. So it gets updates and notification. It gets business support, product support, you'll be getting, and 30 days notification. It's not more, right? But still it has got the enterprise edition. So it has got SSO on the sample. So this is a much needed single sign-on feature, and you get enterprise support. And then one more thing we have seen, right? Here the budget governing and auditing, that extra feature, will be getting budgets and audits. So I think that's the end of this session and end of this video. Yeah, so we can uh, add like more features also. Like for example, like we are accessing this Kubecost using public API, which is not acceptable, from the InfoSec perspective. So probably like if you are having inverse controller running in your Kubernetes cluster, you can leverage it and you can use DNS-based routing or some path-based routing, you can use, and you can access the Kubecost based on that. Uh, Accessing via public API, it's not acceptable. And one more thing I have not shown, uh, Grafana, like I was talking about, right? So, for example, if you access this Kubecost and then just type, Grafana, add suffix Grafana, you'll be able to access the Grafana dashboard. So whatever the data you are seeing in the Kubecost, the same data. So basically, like how, so if you go and see the browse, you'll be able to see a lot of information. All these information are basically collected by Prometheus. Okay. So that information is viewed here. So if I go to Kubecost cluster metrics, so whatever the metrics, we have seen in the Kubecost, same we are seeing here. So if at all, you are using like how to create dashboard, like you can create like customized dashboard also in Grafana. And people might get a question that, probably like you have a Kubernetes cluster with Prometheus and Grafana for monitoring purpose already running. So whether we can leverage the same for Kubecost. As per the cube cost, it is not recommended to use the Prometheus and Grafana which you are already using for monitoring purpose, because the Prometheus and Grafana which comes along with cube cost, the Prometheus basically scrapes very less metrics needed for cost observability. Because normal monitoring, Prometheus it scrapes a lot of metrics basically. So it here in this case, like it scrapes very less metrics needed for the cube cost to use actually. So as per the cube cost recommendation, yes, it's recommended to use the Prometheus and Grafana setup, comes along with, cube cost. Okay. And to use the Grafana, you don't need, separate load balancer or something. As you can see here from the same cube cost load balancer, like they are able to access the Grafana. If at all, like how to create a different dashboard, yeah. So Grafana, like you can create a dashboard. So yeah, that's from the Grafana perspective. I don't know, like if I have missed anything. I think I have covered things and ingress setup. Yeah, if at all you want, let me know. Like I will create a separate, video on that in quick separate video on that if all you need. Right. So thank you for watching. Please let me know if at all you need, in the comments, if you have any clarification. And also, this is my first video in YouTube. Yeah, please let me know your feedback. Thank you for watching. Thank you for time.